Hello, welcome back. This is Franklin from Ask Franklin YouTube channel. Today we are still looking at completing the configuration of OSPF version 2 on multi-access network. We've already done the first version 1 and 2 of this video, and our requirement was 3 routers and 1 switch, which was physically could be configured through the console port, but since we are using a simulation software packet tracer from Cisco and Cisco proprietary devices, we'll just go ahead and configure this network with this IP addressing table. What I already have here is the file, the network setup here on the stage with router 1, router 2 and router 3, and this is the switch on the network. We can see that the the interface for the switch, the fast internet interface 0 to 1 to 3 are up, and I've configured the IP address on the interface on router 1. So I'll just start now with configuration of the IP address on router 2. So router 2, so interface gigabit fast internet 00. From the addressing table on router 2 we have 192.168.1.2 255.255.255.0 as a subnet mask. So go ahead and configure that on this interface. IP address 192.168.1. Was that dot 2 earlier? So 1.2, yeah, dot 2, and the subnet mask was 255.255.255.0. Next we'll just make this bigger to enlarge the screen. Yeah, okay. And this interface had a loopback 0 interface with a .31.22 IP address. So interface L0 IP address 192.168.31 what is 31.22.22, and the subnet mask was 255.255.255.255. Okay, that is the interface IP address table done. So we'll just go ahead and do the same on the router 3. The IP address table on that was 192.3. I think it was 255.255.255.0. Just to verify that anyway. Yeah, that's correct. And there is 31.33 in the loopback interface. It has verify that anyway. So 3, yeah, seems to be correct there. Okay, the whole interface now are configured with the corresponding IP address from the IP addressing table. So we'll now go now issuing the OSPF command. So we'll start with router OSPF on the with a process ID of 10, and we advertise the network on the on this router is a 191.3 network on 31.3 network. So network is 192.168.1.3. Since in OSPF the subnet masks are done on inverted sequence, so go with is 0 dot 0, and where you find the 255 is 0, and dot 0 dot 255 then, and this is in area 0, and we advertise the network, the loopback address as well. Network 192 not 168. So it's from agencies with corresponding network 168.1.31.33, and this is inverted mask 0 dot 0 dot 0 dot 0, and the area on the OSPF is on the area 0, because we're already using one access area anyway. So just a point of hint here, the in the election process of the backup designated router and designated router, the if there is no process ID, the election process uses the interface with the highest priority value or the highest process ID to elect what router will be the backup designated router or designated router, to ensure that a router always gets elected as the designated router. You can always configure the OSPF process on the router with a high process ID or a high priority interface ID. We'll have a look in details in that later. We finish the configuration of in enabling OSPF on this router 3. We'll exit from here, and we'll do the same on the other routers, which is router 2 as well. Router OSPF with process ID of 10, and we are advertising what network here. Network on router 2 to be advertised is 22 and 31.22 and 1.2 network. So go ahead and advertise that network now on router 2. Network IP address is 192.168.1.2, and the subnet mask inverted 0.0.0.255, and area 0, and we advertise as well the loopback interface IP address, which is you see you've already established agencies with the an adjacent network, and we'll issue the show OSPF command to see what router has been elected, the backup router and the designated router, or the backup designated router. So just to complete the loopback interface IP address, network is IP address is 192.168.31.22 with the inverted subnet mask of 0.0.0.0 and area 0. We should always ensure that we issue this area 0 command. If not, it will prompt us with an error. Okay, look like we have done everything successfully here. We exit from this command line and complete the process on the router 1. On router 1 to issue the same command is already trying to establish agencies with an adjacent router. Router OSPF10, and then the network here, where network was 192.1.1, IP address was subnet mask was 255.255, no, inverted, sorry, 0.0.0.255. Am I correct? Yeah, we are. Oh, you see, because I didn't issue the area 0 command, I was prompted with that error, area 0. And the next network, to save myself of typing, because I'm lazy, just issue is 3111. Okay, that has been accepted. Okay, here we'll just issue the some command now to see if what we configured all work correctly. So we issue show IP OSPF neighbor. Yeah, you can see this router is the backup designated router because it has the process ID, the probably second highest process ID, and is got a full because it has the highest IP address. If there is no process ID as well, the interface with this highest IP address will be elected as the designated router or the backup designated router. So this has established agency with router 2. So that's router 1, and if we issue the same command on router 2. Exit from there. Show IP OSPF neighbor command. Yeah. And establish agencies with the neighbor as well. And router 3, you should show, no, that's not router 3 as well. Show, you should show IP OSPF neighbor command. Yep, they've all established agencies. So now, to know which router was elected, the designated router and the backup designated router, let me just issue the show OSPF command.